So good afternoon, everyone. So my name is Diogenes Fernandes, and I'm one of the OpenTofu maintainers, and I'm based in Brazil. And be kind with me, it's my first talk in English, like a public speaking way. And it's my first time at KubeCon as well, so let's do it. So today I'm going to talk about how OpenTofu uses LSP to power its text editors, plugins. So what would be text editor plugins? So a lot of people know them for extensions as well, like on VS Code. So this kind of tooling makes it possible to give syntax highlighting, hovering, auto-completion features on your text editor. So all the modern have these capabilities like VS Code, Kate, and Neovim. So what's going to be shown today? So I'm going to explain what's LSP and how it works, and some of the features of tofu-ls. So there's a lot of stuff to show, so I'm going to be brief only of showing hovering and the schema validation. So what is LSP? So LSP stands for Language Server Protocol, and it's the specification on how the text editor should communicate to a language server. It was created in 2015 by Microsoft for VS Code, but it was only open sourced 1 year later with the participation of Codeenvy and Red Hat. So when I was researching about that, I saw a really nice quote from TJ DeVries. He's a coder that is a YouTuber. And he was saying, okay, LSP turns a n multiplied by n problem into a m plus n problem. So what does that mean? So let's say you have m editors, so VS Code, Kate, and Neovim. And you have n language servers, Python, Ruby, and OpenTofu. So before that specification, all the text editors had to implement a server for the language they supported. So yeah, like you have VS Code, so like you have one server for Python, another one for Ruby, and another one for OpenTofu. So the problem, yeah, so like you have less stuff to implement by doing that specification, like by implementing that protocol. Okay, so how the protocol itself works. So the protocol is built on top of JSON RPC2. So RPC stands for Remote Procedure Call. So when you are doing a request using that protocol, you're going to see a lot of methods. And like this is really reminds us of RPC. So the JSON RPC part means that this request and this response have a specific format for the keys they use. So like you have JSON RPC2, you have a method, you have a parameters, and you have an ID for a request. And the LSP itself is going to define the values that are accepted on this request. So like a text document hover, this is specified by LSP. And all the parameters that are sent on this request for like a text document and the position of your mouse. So this is an example of hovering, some part of your text editor. And then on the response is the same thing, like you have that on all the specification for that method. So this is defined by the LSP specification. And okay, so I'm going to present you to the tofu-ls server. So it's released in a lot of different package managers. You can install that on Homebrew, on NixOS, or you can download from GitHub releases. So the code is on github.com OpenTofu tofu-ls, and it's a fork of an existing project by HashiCorp called Terraform LS. We do implement a lot of features from the LSP specification, and we are extending that for others that are not on this list. But for example, some of the methods on the specification does not make sense for using with OpenTofu, like the document call or the color presentation. But yeah, this is like a small list of what we support. Oh, actually. Yeah, so just talking about these features on the specification itself. So for example, if you want to autocomplete your text on the text editor, you have a feature called text document completion. So we support that. And for the other things, we have these names, like definition, like when you have a variable and you click go to definition. So we have support for that. And seeing the references that are being used for output, for example, is supported as well. Actually, just let me get some water. Okay, continuing. So how the text editor starts the communication with the server. So let's say you open your OpenTofu project and you open a main.tf file. So the text editor is going to send a request to the server with a lot of information from the client, like, okay, I am the VS Code editor, I'm on this version, and so there's a concept called capabilities when you are talking about LSPs. So the client can let the server knows what kind of capabilities they support, like hovering, the completion, because some of the text editors do not support some stuff. So they can let the server knows on this first request what they support. And another important part is we can send information to the server to initialize some stuff. So for example, I can use a different tofu binary for when I'm using on a different text editor. I can define a different log file path I can define like a timeout. Like, so when I'm using that on the text editor, I want the timeouts to have a different value. So I can configure that on the client. And when the server replies back that first request from the client, the server can let the client know what they support, because it's like exchange between both. Because the server can knows what the client supports, and the client can know what the server supports. So we can implement differently depending on what's supported. Yeah, so for example, the server supports completion provider, support hovering. We can send a list of comments to the client. So for example, I can run tofu init or validate directly from my text editor without going to the command line. Okay, so that's the first feature I want to show you today. So it's the hover of the text editor. So like you have an output, not working. So like you have an output test and you have a value with a var test on the value itself. And when you put your mouse on top of the value, it's going to show you, okay, this value, this is a required attribute. It can be of any type, and there's some description on the value itself. Okay, so when I put my mouse on top of this attribute, the client's going to send a request to the server. So I'm just repeating, but like the text document / hover is what is sent to the server. And every time you are like dealing with methods of text document, they are going to send the file name of the text document, another parameter. And in this specific case of hover, you send the position itself. So like the server knows where the mouse is. Okay, so now the server has the information of what the client's sending, and what they do with that. So we have another project called OpenTofu Schema. That library is used by tofu-ls to like assemble all the schema part of the code. So for example, we have all the specification on what the output block can have, on what a variable can be. So everything is defined on that project. So there's an important concept that I would like to explain before we go further. When we are using that project, we have two different types of structs. We have a body and we have a body schema. So a body is a type of abstract syntax tree. So every time you define a configuration, this is going to be parsed in a tree structure. And this tree structure have a lot of information of the configuration itself. It has like the attributes of this block. It has the labels and the ranges of them. I think that's the important part, because everything of your code on that tree on that tree structure have the positions of them. So like for example, so for example, this output block everything on that block, it will have the position of it on the body. So like we know where the bracket starts, where the bracket ends, where the value attribute is, where the value of the value attribute is, the var test, for example. So everything is going to be on that body. And the other part of it is the body schema. That's the specification of what the body can have. So for example, I'm showing here the schema of the output. So I can have like a description, and this description is optional, so the client can know, so, okay, this attribute is not required, so I can omit it. I can have like the type of the attribute and the description itself. So in this case, you can see the second attribute is value. There's some description of it. So like you can see like value, typically a reference to an attribute. So this is what is returned to the client. And there's another library that we use on tofu-ls that's called HCL lang. So this library is from HashiCorp as well. And it's focused on powering the LSP. So it's for HCL because like other languages uses HCL like Packer, and they are not specific of OpenTofu. So they do support like in a generic way. If you want to implement something specific, this is implemented on the tofu-ls itself, but we reuse a lot of stuff from that project. So in this case, there is a method called hover at pos. So basically, you just pass the position that you received on that first the request of hovering, and you pass a context. So this context have a lot of information about the schema itself of OpenTofu. So everything that I show you from OpenTofu schema is sent together, and then this project is going to decode, not decode, like it's going to parse the file name that was sent on the context with the schema, and it's going to, actually let me show on that on the next slide. So this is an example of how the body would look like on this configuration that I showed to you. So like you have a root with attributes, labels, and label ranges, and the important part is like every node that's a body have a list of blocks. So in this case, we have a root, like it would be the root module itself, and there would be some different types of blocks. So you can see like the variable, the output, that's the one that I'm hovering, the resource, that would be the last one, and the output block would have like a lot of different attributes, but it would have a body as well. So like it's kind of a recursive searching of where you want to be. So like every node here has a position as well, so that's how you can compare. Like when you are visiting every node, you can compare the position of them and understand, okay, so I'm on the line 1 with the column 1, and this attribute is on the same position. So I know I'm on the top of this attribute. In this case, it would be value. And when you have that information, you can ask for the schema. Oh, so I want to have the information of the value attribute. So I can ask that to the schema. But basically, a lot of the features that we support is like that. Like we give the body and the position of it, and then the code is just like looping through that body to find where exactly what you want to interact with it, what node want to be interacted with. Okay, so now that we have this information from OpenTofu schema, we send that information back on this content field, and it can be a lot of different types, like a raw string or a markdown. In this case, we are using markdown because you can see we can put some extra formatting on it. So for example, the value part is on bold. So like when you see that on the client, they just have different format. And a lot of these interactions have ranges as well, because that's important, like to see on the client what's being targeted and where it is. Yeah, so now that you know this information, that's how we build this feature. Okay, so the second feature that I would like to talk about is the schema validation. So basically, okay, for this example, you have a resource, AWS S3 bucket with a name, and there's a valid attribute, bucket test. So like these resources have specific attributes that are supported for them. And so in this case, I added an invalid attribute that's not supported by the S3 bucket resource. So how the server can know that that value do not exist for these schemas? Yeah, so like, how do we trigger that? So when I'm typing something on the file itself, the client's going to send a request to the server. It's a text document did change. So like we let the server knows that the file was changed, like what was ranged that was changed, and the content itself that was changed, because the server does not need to like parse that. They can have the information. Okay, so that's a really interesting part of the project. So how do we know what schemas are supported on tofu-ls? So every time we are building the project, we run go generate, and we have like some files for downloading that. But we do a request to the OpenTofu API, and we ask the API, okay, what are the 100 top providers used by the community? Like we have these stats, and we get them sorted. Like, okay, the first one be, I think is Docker. So yeah, we get that list of providers of the most used ones on the latest version, and we download that information. So like, tofu-ls creates a lot of different files with some basic configuration of OpenTofu, and we run tofu in each of them, and then we interact with the tofu binary by running a command called tofu providers schema JSON. So like you get to see all the schema from the required providers of a configuration. So that's how, okay, so we download the providers and we create a project for them. And then we ask this JSON information of the providers, and then we save all of that together with the binary. So like every time you are using the project, you already have this information on the binary. And so like this is done on the top providers, but let's say you are creating another project and you are using a provider that's not on the top one or something private by your company. So that's supported as well, but it requires you to run tofu init on your project, because you're going to have like a .terraform folder with the schema of the provider. But after you have that, when tofu-ls interacts with your project, it's going to do the same command that I mentioned before, and it's going to download the provider schema that's used on your project. So we support that as well. Yeah, so for checking that, we call another function from HCL lang called validate file. Basically, just like instead of passing the position, you pass the file name, because in this case, we are looking to validate a file and see if there is any problem with it. And yeah, so this is kind of similar on what OpenTofu does when it's visiting the graph generated, like when you are running plan or apply. And we use something from the HCL lang as well called validator. And this is a list of validators for modules, but there's another list of validators that's used for example, like if you have .tf-vars files, they have some validation on them as well, but they do not use the same list of modules. So for modules, you can check more stuff on the client, on the server. So in this case, like you could see a message with an unexpected attribute, and all these validators that I mentioned before, the min blocks, max blocks, missing required attribute, all of them, they implement a function called visit, and a method called visit, and all of them are going to be run when you are traversing the tree. So in this case, like I am at the unexpected invalid value. That's what I use it. But I do not have any schema for it. As I was mentioned before, like you see the position, this kind of stuff. But for this one, I couldn't find any attribute on the schema of it, of the S3 bucket. So I'm going to append a diagnostic to that, to what the program is doing. So diagnostic is something that OpenTofu uses for returning warnings and errors to the application. So like you can see what's wrong with it. So in this case, like we would be adding an error to the diagnostics and returning that to the user. So after we have this information, in the specific case of tofu-ls, we are sending a request from the server to the client. So like the client is listening at some point, and the server parsed all the file and send the publish diagnostic method to the client. So it sends a list of diagnostics with the position of them, the severity, that could be like a warning or error, the source as well. That's important because multiple LSPs can be used in one file. So it's important for the client to know which LSP generated that specific error. And the message itself, like that would be the problem that show when you see the diagnostic. So there's two ways to do that. In our case, we send information to the client, but the client can request that as well. Like there's a difference between like pull or push in the diagnostics. Like it really depends on what you want to do on your client, but we use push. And yeah, that's how we implement that. So what's next for the project? We are working on some refactor capabilities. So like, for example, you want to change the name of one output and throughout all your project. We do not support that yet. So like we are working on it on part of a hackathon, but probably it's going to be a feature of the project. And improving references, definitions, and implementations because the modules are not working great for that right now. And improving the performance issues because some projects, big projects with a lot of files that are saved on memory for the tofu-ls can be slow right now. And that's it. I would like to thank Gruntwork for sponsoring me on working on OpenTofu. I would like to thank Gamanu, is a community member as well, but like he donated the first extension of OpenTofu to us. He donated the code and even put like a reference on his old project to our new project. So thanks a lot, Gamunu. Ilya, so it's one of my colleagues that was like working together with me to kick off this project from the beginning. So we've done a lot of the refactoring together, and we usually do the maintenance of this project. And to the other OpenTofu maintainers that reviewed a lot of the code and gave a lot of useful feedback to us. And for support, you can open on the GitHub link for opening an issue and talk to us. I think like one of the main points of OpenTofu is the community. So like I started working with the community itself in January, and I contributed to the project, and then at some point one position appeared, and I joined the project since February. And yeah, talk to us there. And do you have any questions? So there's a QR code for give me feedback, but yeah, that's it. It looks I won't have time to questions.
Thank you. This is super important work you're doing. Any questions? Just a quick question for me. How do you go about prioritizing what to work on? Like there's just so much to do.
Yeah, that's a really good question. So like, basically just getting feedback from the community, seeing what the people are requesting. Because like, we do not have a lot of requests from the users, but when we start to see some pattern on that, we are going to prioritize that. But like for OpenTofu, for the core project itself, we have an issue like top rank issues, something like that, and we do prioritize by like reacting. Like when people are putting thumbs up on the issue, they are going to get to the top of the issue. So we know that's important for the community. So it's the main way we have for prioritizing. Thanks for the question.
Excellent work. Thank you.